Hello guys, so this is just a simple lab where I'm gonna describe quickly those different properties about Windows binaries so that you can understand better what was described in the slides. So let's start with this very simple C program. It is just basically printing hello CSTT students. So as mentioned in the slides, the first step is the source code, right? Once it's the source code, then we need to create the binary. So in order to create the binary, we need to go through the compiler and the linker as described before. This is an IDE called NetBeans, which basically can help you to develop C, C++ programs, but it is open source, it is free to use, but you can use many other ones, or even the commercial one, which is Visual Studio from Microsoft, which is highly recommended, but you need to pay for the license. Let's go here. Don't concentrate on the different details of this IDE, because as I said, you might want to use your own preference. So in this specific one, we go to run build project in order to compile and build the binary. In the top, in the bottom, you can see that it started running, and it calls the make, which is in order to compile the binary. It come up with some specific functions, but eventually it will create the executable. Here you can see the hello.exe, which is going to be the executable for this specific source code. If we go to that specific folder, we can see here hello, and if we execute it, it just says hello CC students. So now we already have the executable created from the source code as mentioned in the slides, right? It goes through all different processes like compiling. As I said, it's kind of complex, but for us as a malware analyst, we don't need to concentrate on many of those things. I'm gonna talk about the ones that we really need to know. I'm gonna open the binary with LordPE so that you guys can see how it looks like. So we have here LordPE, we click on PE editor, and then we click on our binary. We have here all the properties of the PE. As you remember, it used to have the PE header information, and in this case it doesn't show the MC header. You remember the MC header, which comes with is the first information in the binary. So for that, I'm just gonna open Hue, which is our demo version, and I wanna show you here just how it looks, the DOS header. So we go to the same folder and we open it. So here is Hue. This is the demo version, and it has different views. The first one is just like a raw view. The second one is like for you as an X editor if you want to change something, and the latest one is the disassembler, which basically is going to transform those bytes into assembly operands. Okay, so here I'm just going to show you, as you remember, here is the MC header that it will be present in every single Windows binary, and all those different structures as described before. But I just want to remind you about the P header. If you remember, the DOS header was 64 bytes, which is 16 here, the first row, 32 bytes in the second row, 48 and 64 is all the bytes from the DOS header. And in the last double word, which as you remember is 4 bytes, it is this specific one, we have 80,000. If you remember, this is in little endian, which means it is stored in memory in a reversed order. So we just need to reverse it again in order to have the final number, which in this case is 00000080, which means at offset 80 we have our P header. So if we go to the offset 80, which is right in the left side, we can see the count. Here is the offset 80, as you can see, and here is where we have our PE00, which is, as you remember, the starting of our PE header. Now you can see here in the left side that it says 4000 and then 80, right? The 4000 is the image base. So coming back to our LordPE, we can see the image base, which is 400,000, right? That means it is the address in memory where the binary is going to be loaded. That's the reason that we have here at the really beginning in the 4D, we have the 4D5A. You see that? Let me just highlight it here. We have the 4D5A, and it is in the 400,000 address because that was the image base in the properties. Okay. So that's all from Hue. We're gonna talk more about Hue in another course. I just want to show you the DOS header. So now we are here with LordPE with all the different options from our binary. The entry point, which is relative address from image base. The image base is this one. So that means that our entry point is image base plus this relative address. In other words, it's gonna be 4012A0. Okay, we're gonna see that in a second. We have many other properties, as you can see, and we can always change anything. You see here, you can always change it, right? But be careful, because you change it, probably you can spoil the binary. You need to know what you're gonna change. The size of the image, base of code, where the code is gonna be executed. In this case, it is a text section. I mean, all the different sections that we just described in the slides. We have here the number of sections, which is 8. You can confirm that in the right side if you click in sections. If you count all of those are 8 sections. We have the directories. But before that, we have here the size of header, the characteristics, which is basically what is the properties of this specific binary. You can see here that it is a 32-bit machine expected. Here, this DLL is going to be enabled only if this is a DLL. As you remember, Win32 binaries, DLLs, and executables have the same format, but with this specific flag, the operating system knows that this is a DLL. If you see in the current value, when I click on DLL, it changes to 2307. If we remove it, it's going to say 307 only. So by putting all those different values, that current value is going to change, and based on the final total, is going to tell the operating system if we are talking about a 32-bit binary, DLL, or let's say that it is large address aware, so it's gonna put another value. Sometimes it doesn't change. I mean, always, sorry, it always change, like through 327 here, and if you put more values, you can see it is incrementing. So based on whatever you enable, it's gonna give us a total value, which is gonna be used by the Windows operating system. Okay, so this is the characteristics. The checksum is very important. So basically, every time you change something in the binary, the checksum is a check to know if someone was altered in the binary. For drivers, for example, the checksum must be always recalculated if you want to change something. Otherwise, it won't be loaded in the operating system. And all the different options. Let's go to the sections. We have all the sections. As you remember, the text is for executing code. The data is to store variables, global variables, local variables. We have all those different sections here. Our data is similar to data. We don't have resources. That's why we don't have the .rsrc section name. Those sections are optional. You can put any name. The most important thing is here. The offset in memory, virtual offset, in this case is 1000. We're gonna check that in a second. The size, the raw offset in disk, like that means not the binary in memory but on disk. Where is the offset, the size, and the flags, which are the characteristics that we just saw. Okay, that's the same for all of them. And finally, we have the directories. Directories, as you remember, is very important, that the directory table, which is going to tell us the export table, which is always used by DLLs. We don't have anything here because this is not a DLL, which is going to show us all the different functions that specific DLL is making available for any program to use it. Okay, the import table is all the DLLs being used by our program. If we click on this dot options, we can see that it has kernel 32, MSBCRT, which those are added by the compiler. Is very default setup. Okay, but the important thing here is that all of those DLLs have the API names. Those API names that you see here are also known as symbols. You remember we talked about symbols? Okay, so we have the symbols of the kernel 32, which are the different options: that DLL critical section, exit process to exit, find close to close the handlers, find first file, you know, all those different APIs that not necessarily are being used by our program, like we create them, that we add those specific functionality, but those comes as default APIs in the compilation phase. Okay, so let me show you something very interesting here. So if you remember, if we want to add more functionality to our program, that means we probably will need to add another DLL. And if we add another DLL, we should reflect it here. So keep in mind that we have kernel 32, MSBCRT, MSBCRT again, and libgcc. Okay, nothing else. So let's change our program and try to alter it in order to add more functionality. So we come back to the source code, and now we're gonna add a message display. I mean, instead of putting just the print that we were doing here, we're gonna say send a message box. So if we do that and we try to compile it, let's try to compile it. There is an error here, right? It says unable to resolve identifier message box. It doesn't know what it is. So if we try to compile it again, okay, we're gonna get an error message. It is gonna say exactly, let's find it here, message box was not declared in this scope. So when it's trying to compile it and it sees this specific message box API, it says, hey, I don't recall seeing this specific scope variable. That means it doesn't recognize it. The reason is because we need to tell them that that specific API is in another header. So for this reason, we need to add here include, oh my god, include windows.h. When we add that, you can see that right away this must change. So if we save it now, right, and then we click on compile, build process again, we can see that now there is no more errors. And then it says, oh, okay, so the message box is referred in that specific header, in this case Windows H, which is adding more libraries. Let's see what was the new library added. So we come back to our PE editor, we open the hello one, and before doing that, I want to just confirm that we have now the new binary compile, which is supposed to print a hello message. Oh, it is not possible because we are editing here. So let's just close it and rerun it again. So we can see that we have our hello message as expected. Okay, so that confirms our changes. So now we come here and we try to edit this specific binary. If we go to directories and we go to import table again, do you see the difference? Now we have user 32, which was being added with the new API message box. That's exactly the purpose of the linker. So the linker detected that there is a new API, so it's gonna create all the necessary directory table with all the different offsets so that the binary is able to find the message box in memory in order to call it whenever it's needed. But most important, our import table was changed because we added new functionality, as we said before. Okay, so that's all related to directories and all the different sections. And let me show you something here in the sections. Also, you can always change this. So if you click on edit, you can always change the section, like the virtual address. In this case is 1000, the virtual size, the row, anything, or the flags, which basically, if you notice, the text section is always executable, always, but it should not be writable, right? It should not, because you are not writing, you are just reading and executing code. That's the purpose of the text section. That's the same for the other sections. So, but you can alter it. So now let's go to these properties. So we have here image base. As you can see, it is in the 400,000. That is telling that to the Windows loader that whenever you run this program, tries to put it in that specific offset in memory, and you need to start executing at this relative address, which means 412A0 address. Okay, sorry, it's not 1200, it's 40 and then 12A0 address. That should be the starting point of execution. In order to confirm this, we can run it in a debugger. Don't be scared yet. We're gonna talk about the debugger in a different course within this certification, but I just wanna show you how it looks like. Okay, so we just come to Immunity Debugger, which is one of my favorite debuggers. We wait for it to load. It is coming a little bit slow, but anyways, so we come here to File, click on, we have already here our address. So if you notice, the debugger is gonna run and when it stop, it's gonna stop before starting executing, and it's gonna stop in the entry point. You can see here it says 4012A0 is the entry point, and the left side you can see it just stopped there. Before executing anything, yes, it stopped there. So we can confirm what we said before, right? With the properties of this hello binary was saying, okay, so the image base starts at 400,000, and the entry point is the relative address, which is image base plus entry point, which is 40 and then 12A0. We can confirm that exactly here. Okay, so that was the way the Windows loader knows where to load the executable in memory. It's very funny because if we change the entry point, it will jump wherever we tell him. And actually that's one of the old techniques being used by malware, which is gonna say, hey, I'm gonna change the entry point of this binary, which is, let's say, your calculator in Windows or any other valid binary. Is gonna change. It's gonna tell the malware, I'm gonna infect this binary, I'm gonna change the entry point to a different offset in the binary so that I can execute my malicious actions, and then I'm gonna come back and display the calculator so that the infected user doesn't realize it. We're gonna talk about those file infections actually within our course, in the malware tricks course. So make sure to check it out. But so far here, I'm just gonna change this to something so that you can see how it will jump into a different location. So if we come here to our binary, let's say that we wanna jump right in the jump EAX, which is at offset 4012F5. Okay, so let's change this to 12F5, and before saving it, I'm just gonna close the debugger. I change it here and I click on OK. It didn't allow me because it was being opened by the debugger, but here 12F5. Okay, and then we click on save, and then we click on OK. If we reopen it to confirm the change was made, we can see that now it is 12F5. Okay, so now if we run this in the debugger, check what's gonna happen. The entry point changed and now it started at 12F5 as expected. So that's the purpose of the entry point. Okay, so that's something that was very important for you guys to know. Now let's go to another example, which is basically DLLs. So as I tell you, the DLLs are the same format as the Windows binaries, but they have just a different bit, which tells the operating system that it is a DLL and it's not an executable, plus it has an export table. So let's try to find a DLL, any DLL in Windows. This is Windows 8, by the way. So we found this Twain. Let's open it. Oh, invalid PE file. Let's open the next one. Twain 32. Okay, so we have here this DLL. We know it is a DLL, right? So if we go to the characteristics, you can see that the DLL option is enabled as expected. Okay, that's the first thing. The second thing I want to show you is the export table. Now we have information in the export table because it is a DLL. If we click on it, it's going to say, okay, for this DLL, I have these functions available. So anyone in the system that want to use this Twain 32 DLL, you can use my functions, which is the MS entry, choose dialog, about dialog, win dialog, and info hook. Don't care about the function names, but understand that the DLL is exposing its functions, and the way it can tell other executables in the system the functions available is by the export table. Okay, so that's very important for you guys to know. By the way, we're gonna also explain how you can analyze malware in DLLs. So keep reading our different labs. And finally, guys, if you remember, we talked about something that was the TLS, directory table. So let me show you here. We have an exercise which is the TLS. Okay, so this TLS, if you remember in the slides, it is the thread local storage, which is basically when you have multiple threads, you have a place where you can store variables, values from that specific thread. Normally it's not used by the binaries, but for malware authors, they use it in order to infect the system before even starting executed at the entry point. As you remember, the debugger is going to start at the entry point, and then from there start executing the main function. But the TLS, if the binary has a TLS section, it will execute that before the entry point, which means you might be infected before even started running the executable. So let's see how that works. So we have this specific TLS, okay? So we can see that he has the entry point in 1308. We can see here also that the directories, we have the TLS table, which confirms we have TLS. That's very important for you guys to know, because anytime you are reviewing malware, you need to know where are all those entry points, which means where the malware can start executing, right? An easy way to identify those is obviously by looking at the directory table, as we can see it here, but also you can open IDA, even the free version. Again, don't be scared. We are not dealing yet with reversing scenarios, but I'm gonna show you how we can identify the entry points. So we go again to exercises. When we open the TLS binary, okay, it's gonna start loading, and if we click on Control E, okay, Control E is gonna show us the different entry points. So IDA is still analyzing the binary. Let's give it some time. It is done. If we click Control E, we can see that it says, okay, we have our entry point, as we saw, 401308, but wait a second, you have another entry point, which is 41,000. At this moment, you guys, as experts, sorry, as experts in the in malware analysis, you can put a breakpoint in this one. Okay, so let's see how it works, and then let's see the consequences. So let's say that you have a binary which is malware and which has TLS callback and directory enable, which means the malware authors wants to execute something before even you try to analyze the malware. Let's run our TLS. Okay, when we run it, see this, it says calculator executed, and then it says press enter to continue. Let's see the source code. In the source code, we have the main function. The main function is supposed to print a message box saying hello defender, which is, as you know, the first instruction being executed in any binary. But since we added a TLS callback, it is executing the calc exe, as you can see here. This is a TLS callback. Don't worry about the syntax, about those things. Just see that if we added the TLS callback, it is executing the calculator as you saw. Then it's gonna say press enter to continue, so that we can confirm that after that, it's gonna print the message box. So let's do that. We come here and one second, I just get out. So it says press enter to continue. When we press enter, the hello defender is being printed. That means that even before running the main function, it was executing the calculator. In a real scenario, instead of a calculator, it's going to infect your system. Now, what I'm telling you about TLS, because normally we as a malware analyst, we will always try to run the malware in a debugger. Okay, we will try to open it in a debugger and then start analyzing it. But as you know, by the time the debugger opens it in the entry point, we are already infected. So let's see the normal scenario. So we're gonna say, okay, let's try to analyze that specific binary. So we go to whatever it is, the folder. In our case, is in C. Then we go to temp, example. And when we open it, let's see what happened. We got just a message, don't worry about that. And we see that the calculator pops up again, but we don't have anything here. You see, the debugger doesn't even stop in the entry point as we saw before. And it already executes the calculator. That means we are already infected. And as a malware analyst, we don't know. We are like, okay, so let's start analyzing it. By the way, we need to click on enter to continue. In this case, because I want to show you step by step, right? But in a real scenario, you don't even need to click on continue. So we just click on continue. And finally, the debugger says, oh, I'm going to the entry point. Okay, so it stops in the entry point, and it already executed the calculator, right? But at this time, the analyst is gonna say, okay, so let's see what it is doing. But as you can see, you're already infected. So if we just let it run, it just pop up the hello defender message. So it's very important to understand TLS callbacks so that you guys don't get infected before even starting analyzing. And that's all, guys, related to the basics. So hope you enjoy it.